Good morning, this is Mr. Precella. I'm with my favorite blended college algebra class, and today we're working out the review for the Math 373 final quiz. One of the first things we did in this class was work with imaginary numbers, so I bet you someone will remember how to do this. We want the square root of negative 144. We want to express it in terms of I. So I think the first thing I would ask is 144 a perfect square?
Yes.
Yes, it is. What's the square root of 144? 12. And since it's negative, what do we have to stick on? An I. Well, there's no work really to show there. Let's have the final answer of 12i. Familiar? Yes? Okay. Here, number 2. They won't all be that easy, I can assure you. Same instructions expressed in terms of I. We have the square root of negative 20. Is 20 a perfect square? No. What's the largest perfect square that divides evenly into 20? It's not that big. No, I don't think 2 or 10 are perfect squares. 4. Here's how you think of it. The square root of negative 20, you can think of it as a negative 4 times 5. Now the square root of negative 4. Well, the square root of 4 is 2, but since it's negative, we stick on an I. What do we do with the 5 underneath the square root? Keep it under there. I agree. To give us a final answer of 2i square roots of 5. Any questions there? Oh, number 3. Solve using the quadratic formula. Well, we certainly use the quadratic formula a lot this semester. Seemed like those problems just popped up all semester long in various homework assignments. So, what do you think I'm going to do first? I need the equation set equal to 0 on one side, and I want a positive leading coefficient on the other side. I want that 2 to stay a positive 2 there in front of the x squared. So I agree. Let's move that 1 over. So we'll have 2x squared minus 5x. Two x squared minus 5x minus 1 is equal to 0. And now we can identify our a, b, and c values. What does a equal? 2. B? Negative 5, I agree. C? Negative 1. And maybe we should write down the quadratic formula just to remind ourselves of it. I'll write it over here. X equals, it's a fraction bar. What have we got on top?
Negative b.
Negative b, I agree.
Plus or minus.
Plus or minus.
The square root of.
B squared.
B squared.
Minus 4 times a times c.
Well said.
Minus 4 times a times c all over
2 times a.
2 times a, I agree. So we're going to make our substitutions. Minus b. What are we going to have here?
Positive 5.
Okay, that says change negative 5. It's changed to a positive 5. Minus a negative 5 is a positive 5. B squared.
Negative 5.
Negative 5 times negative 5. That's going to give me 25. I agree. And if I remember correctly, the minus 4 times a times c, I would do on my scratch paper. Here's my scratch paper. The minus 4 times a times c. A was 2, c was, so negative times negative, that's going to become a positive. A positive 8, I agree. Okay, so a plus 8. What have we got on bottom? 2 times a. 2 times 2, I agree with 4. So we have 5 plus or minus the square root of, what have we got under the radical? 33 all over 4. Can we simplify the square root of 33? Is 33 a perfect square? No. Are there any perfect square factors of 33? It's 1 times 33 or 3 times 11. None of those are perfect square factors. So what do we conclude? This is the answer. There it is. We're finished. We can't reduce it any further. Any questions there? Okay. Number 4. It says to solve the equation, and don't forget to check. They're being pretty nice there, reminding us we need to check. We have this is an equation with fractions. We know fractions are not always defined. When is a fraction undefined? When the denominator is 0. Remember, a number divided by 0. That says, no, you can't do that. That's undefined. So as long as we don't get a number that gives us a denominator of 0, we're fine. So let me rewrite the problem. 7 over 5y minus 2 is equal to the fraction 5 over 4y. There's the equation we're trying to solve. Normally I multiply both sides by the least common denominator to eliminate the fractions, but I noticed something. Here we have a fraction equaling a fraction. That's called a proportion. I recall that happening sometime in the homework weeks ago, and I'm mentioning there's another way of solving a proportion. If it's a fraction equals a fraction, what could we do? Cross multiply, I agree. Multiply and multiply. Notice it makes a cross. To me it's an X, but I guess we can call it a cross. That's why it's called cross multiplication. You take 7 times 4y is equal to 5 times 5y minus 2. And 7 times 4y, we know that that's 28y equals, what have we got on the right-hand side?
25y minus 10.
Good. Distribute to give us 25y minus 10. This isn't quadratic. Notice it's linear. There's no y squares. I just collect all my y terms over here by doing what?
Subtracting 25y.
Okay, 28y minus 25y, that gives me 3y is equal to negative 10, and then divide by 3 to give us negative 10 over 3. And we have to remember, they want us to remember that we can't have a denominator of 0. Will negative 10 over 3 give us a denominator of 0? 5 times negative 10 thirds minus 2. It wouldn't give me a 0. I would need a 2/5 there to make that equal 0. What about 4 times negative 10 thirds? Does that equal 0? No. So negative 10 thirds is a perfectly acceptable answer. So here in the ABC option of My Math Lab, you'd say the solution is negative 10 thirds. Any questions there? What about number 5? Solve the inequality. Oh, who remembers the name of that little process we used to solve inequalities? Cut point method. Yes, we would use cut points to solve these inequalities. Let me write the problem down. X squared minus 15x plus 54 is greater than 0. First thing we do, we ask ourselves, when is the inequality equal to? I'll remember the steps. The first thing we do, we'd ask ourselves, when is the inequality equal to 0? This is quadratic, so hopefully it's factorable. Let's see. X squared factors as, well, x times x. We know something nice about the signs. What do we know?
They're both negative.
Okay, if the last sign's a plus, you have 2 of those first signs, so I agree. And then 54. What times what will give you 54? This is a simple trinomial. That means that the terms have to, the numbers that you use have to add or subtract. In this case, they have to add to give us 15. So 54, let's see. 1 times 54, 2 times 27. 3 times 18, 4, 5, 6 times 9. Well, there are actually 2 pairs. 18 and 3 subtract to give you 15. 6 and 9 add to give you 15. Which one should we use?
3 and 18.
I think that 3 and 18, because the minus and the minus, if we use a 3 and an 18, we're going to wind up getting a 21, not a 15. So I think we need 6 and 9. Let's check. Do I have a red pen some for you? Let's check. Well, this is red, but I don't think I guess I'll use purple. Let's check this. What's the outer product?
Negative 9x.
Negative 9x. What's the inner product?
Negative 6x.
Negative 9x minus negative 6x gives us negative 15x. Is that what we needed?
Yes.
Yes, it is. So set each factor equal to 0 to give us x equals 6, or
X equals 9.
for my solution cut points, I have 2 solution cut points. The first thing we do, we ask ourselves, when is the inequality equal to? And those give us our solution cut points of 6 and 9. Let me ask you something. When we label these numbers on the number line, how are they going to be labeled? Open or closed? These numbers make the left side equal the right side. Is it okay to have equality? Do we have equality there?
No.
No? Oh, that little line I drew, that little arrow, but that's not the problem. The problem is just a greater than, not a greater than or equal to. So I agree, we're going to label them with open circles. Second step, we'd ask ourselves, where is the inequality undefined? We want to know, we're finding DCPs was the abbreviation. What do we conclude here with this problem? When would this stuff be undefined? Remember we said an expression is undefined if it's a number over 0. Is that going to happen here? No, the inequality doesn't have any fractions, so there are no denominator cut points. Third step, we draw ourselves a number line. We have 2 cut points, 6 and 9, that we label with open circles. And during the all-important factoring stage, looking at this factoring stage, we should be able to make to answer this next question. Do I need to check every interval, or can I just check one interval and assume an alternating pattern?
Check one.
Just check one. Remember, if you have distinct factors in the factoring stage, then you expect there to be an alternating pattern. Now, if this had been a x squared minus 12x plus 36, where you factored x minus 6, you would have needed to check every interval. But if you have different factors, no repeated factors, then you can assume an alternating pattern. So, what number do you think I'm going to test? What's my favorite number to test? 0. Which interval contains 0? Interval 1, 2, or 3? 1. So I'm testing 0 right here to give me, testing in the inequality, we get a 0 squared minus 15 times 0 plus 54 is greater than 0. True or false? 0 squared is 0. Minus 15 times 0 is 0. 0 plus 54 is 54. 54 is greater than 0. True or false? True. So we shade here. Suppose we had tested 7 or 8 here. What would we do? Shade or cross out? Cross out, it would have been false. Suppose we had tested 10 or 10,000 over here. What do we expect? Shade. That would have been a true statement. And our final step is to express the interval using interval notation. Express the shaded intervals using interval notation. Am I going to have any rectangular brackets in my interval notation? I use rectangular brackets when I have what on the number line? Those shaded circles. These are open circles, so no brackets. It's all parentheses. So parentheses, how do I say this is the fifth step? Okay, negative infinity, comma, 6, parenthesis, union, and put that little union symbol, and now it's another parenthesis. How do I say all the numbers to the right of 9?
Infinity.
Well, before the infinity I have to say 9, comma, infinity. Remember, use parentheses. Use parentheses after a positive infinity, before a negative infinity. Use parentheses at open circles. The only time you would use a rectangular bracket is if you had closed circles on the number line. Any questions there? Let's see, so there, does it all fit? Well, I guess that does it. Any questions? Okay, we're going to take a little break now. We'll be back in a few minutes.